The USB on the NESI board can be used both as a serial or a COM port and as a USB slave. For usage as a USB slave, you're going to need an SD card plugged into the primary SD card slot of the NESI board. In this video, we're going to be focusing on the NESI board's ability to communicate with the computer's serial port.
To actually get to coding the USB module, we need to install a few things on our computer. One of these is the actual NESI source code. We're not going to start from the kind of base which we've used for all of our other videos. We're going to actually download it online. Now this can be accessed from any GitHub repository that has the NESI's code. I'm just going to take that and I'm going to put it on my desktop here. And I'll also extract it, just like so. Now the driver is contained in this folder here. So when we get to actually installing the driver for the NESI board, we're going to install it with that directory there. So the next thing we have to install is a serial port monitor. If you're familiar with Arduino, then you know that the Arduino board can communicate with the computer through the serial monitor up here, which you can click on and it brings up a little window with kind of a text communication. The simple serial port monitor which you're going to install is kind of like that, except it works for any sort of serially or any sort of device that communicates with the computer through a serial interface. So I'm just going to go ahead and click download now, and then I'll select a direct download. Once that's downloaded, I'll go ahead and click through the installer here. And you'll notice it brings up a window like this. Now I've installed this before, so it does say NESI COM interface here, but I'll walk you through the process to get that there. So now that we have these two files, or one of these programs and the files downloaded, we're going to go and open up MPLABX and import that project there. So I'm just going to click on this little icon up here, which is Open Project, and I'll actually navigate to that folder that we downloaded. It should be on my desktop. It's called NESI Master 4. So I actually downloaded the wrong zip file. I'll put the correct zip file in the description of this video. But now I'm just going to go and click on the little Open Project logo up here, and I will navigate to on my desktop. It's called NESI Source, and then in Build, select Core, and then click Open Project. Now in here, you can go and open source files, and you'll notice that there is no main. That's because the mains for source files are contained in the app folder, but because I want my main to be readily apparent, I'm going to go and delete the app folder, so there are no duplicate mains. And then I'll right click on source files, and I'll click New, C source file, and I'm going to call it main.c, and then I'm going to click Finish. That'll create a main.c file, and I'll go ahead and begin by including nesi.h. And then I will put our main loop is going to be int main, and then in parentheses void, it's not going to take any parameters. And then I'll go ahead and put my while loop, so while, and then I'll type in my return statement. And I'll just put in nesi.init. So now I have a fully configured main file, and I can go ahead and start putting some USB code in here. So I'm just going to save this, and then I'll put in include, and then the USB library, so include, and then usb.h. That will include the USB library for the NESI board, and then I'm going to just initialize that with usb.init. And because when I plug it in, I don't want it to initialize right then, I want it to wait just a little bit of time to allow all the terminals to make a connection, I'm just going to be safe and put in a delay statement. So delay for like 1 second, so ms 1000. It's 1000 milliseconds, and then I'll go ahead and connect it to the computer by using the USB.connect function. USB.connect. USB.connect is interchangeable with USB.attach. So if you want to use one or the other, you can. So now we're just going to make a simple program that detects a keystroke. I'm actually going to put in ledb.dutycycle 1, just as kind of an indicator that this initialization function ran correctly and it's not getting caught up with anything. So now I'm going to go to my while statement, and I'm just going to type in what I want it to do. I want it to detect a button press. I'm just going to make a program that when you hit the button, it just tells the computer that the button was pressed. So detect a button press, and if it's a keystroke single, we're going to disable button presses. Then at the end, we're going to re-enable them, so enable. And in between here, we're just going to, first we're going to tell the computer that the button was pressed. And next, we're just going to, I want some indicator that the button press is actually detected, so I'm just going to turn the red LEDs on. And then I'll just wait for like 100 milliseconds, just so I can see that it actually ran. Then I'll turn the red LEDs off. Alright, so for detecting the button press, if you don't know how to do this, you can go look in the button code module video that'll explain it. So I'm just going to put if button.getStroke. If that equals a keystroke single, so if it's been pushed once since this getStroke function has last been called, so stroke single. And I'll go ahead and add in some brackets here. And then I'm just going to go ahead and quickly disable button keystroke detection with button.disable stroke and button.enable stroke. Alright, so first thing we're going to do is we're going to tell the computer that the button was pressed. We can do that with the USB.print function. So if you'll go down here, print, it takes a string, so we're just going to use print, and then we're going to pass in quotes, a string. So we're going to say something like button was pressed. And then we're going to turn the red LEDs on to 1 duty cycle using the LEDR.dutyCycle function. And we'll also turn them off. And then in between we're just going to delay using the __delay_ms function, and we're just going to type in 100 milliseconds. So that code should run, and we'll go ahead and program our NESI board with it.
So I've just programmed the NESI board, and all I'm going to do is plug it into the computer. I'm not going to press the button right now, or do really anything. I'm just going to observe that those blue LEDs are on.
So when you first connect the NESI board, with any luck, when you go to the Start menu, go Start, and you go Devices and Printers, there should be a device named NESI board V1.2 or something similar. That's your NESI board, and what you're going to do is you're going to right-click on it, go to Properties, then you're going to go to Hardware, and then click Properties in the lower right-hand corner, then click Change Settings, and then you're going to go up here to the Driver tab, and you are going to click Update Driver. Now in this dialog that pops up here, you're going to click Browse My Computer for Driver Software, and then you're going to navigate to the source folder for your project, and that will contain the driver file. So mine is under NESI source 1.5.3. I'm going to click OK, and then I'll click Next. And then you're going to now the driver is installed, so you can go ahead and OK out of all of these windows. And now, with any luck, we can go ahead and start simple serial port monitor. Now, upon further research, I guess, I have noticed that the exclamation mark I put in here earlier was actually causing some issues, so just go ahead and remove that. So back into the serial port monitor, when you open it up, you should click on this right up here. You should just click on it, or you can go navigate down here and click on Config. Those will do the same thing. Now, for port, we're going to select COM22, the NESI board COM interface. If that's not showing up for you, make sure you just unplug the NESI board and re-plug it in, or try using a different USB a plug on your computer, because I've found that to be very, very finicky. So if you're having trouble there, just make sure you try a few different things, and if you need support, feel free to post about it on the forums. For the baud rate, we're going to use the default baud rate of 9600. The data size is going to be 8 bits, and we're not going to have any parity. And we're going to have 1 stop bit. That's just kind of the default for the USB serial interface. So go ahead and click Apply, and then you're going to click Start. It says Start Monitoring. If at any point you get something that says something like Monitoring Failed, let me see if I can get that error for you. Like that. What you're going to do is you're just going to want to unplug the USB port. You're just going to make sure it's stopped and try replugging it in, and then just click Start again after that blue LED illuminates. and it should say monitoring started. Now every time you push the button, you'll notice that it says button was pressed up here. And I actually added a new line character at the end of it as trying to experiment with it just off camera. That's not really necessary, but every time the button is pressed, you'll see that we get some feedback on the screen that says it was pressed. We're able to have the NESI board send data to the computer when the button is pressed. We also kind of want to have that go the opposite direction as well. So when you send a single character from the computer, so from the serial monitor, if you go right, if we just send like the letter R or something, we could have that turn the red LEDs on, for example. So that would have some two-way communication, and we can do that by using the USB.read function. So we're just going to write what we need it to do. We're going to read 1 byte from the serial monitor, or from the serial port. We're going to read 1 byte from the serial port, and we're going to store it in a byte array. Now we haven't declared that byte array yet, so we're just going to go up here and we're going to declare the byte array. We're going to see if the first element in that byte array is equal to R. And if it does, we're just going to turn the red LEDs on. And if the first element in that byte array equals O, we're just going to turn the red LEDs off. Now, these characters are completely arbitrary. You can set them to something else if you want, so long as you remember that when you send them from your computer, it'll do a certain action on the NESI board. We're going to go ahead and use the USB.read function here. So USB.read, and you'll notice it takes 2 arguments, the string and an unsigned character. Now, the unsigned character equals the amount of bytes it's going to read from the USB serial port. So if we just do, we're only going to want it to read 1 byte, so just 1 for now, because we're only going to be storing and reading only 1 byte because it's a single character. You could do more, but that would kind of change the structure of the code a little bit. No, and then I did forget something here. We need to clear the byte array, so that way it doesn't keep performing these actions. It wouldn't be that harmful to keep turning the red LEDs on, but if you're doing something else that only needed to be performed once, you wouldn't want the red LED, or you wouldn't want something to happen more than once. So we're going to clear the read array, or clear the byte array. Now, back up to this USB.read function. It takes a string and the integer for the amount of characters it needs to read. Now, the string, so if we have a string in here, if we actually look at what a string is, I'm just going to declare a string variable, and if you control-click on it, you'll see that it's defined as a character star. Now that star means it's a pointer, which means that it actually refers to the location of it. So when you declare a string, in this case I called it test, test actually contains the location of a character array where that string is actually stored. It's kind of a hard concept to grasp. Now, because it's a character, a char star, we can replace that with, and whatever code we had that used the test variable would work exactly the same way. Now, if we also look at the byte data type, byte right here, and if we control-click on that, we can see it is a uint8, and if we click on control-click on uint8, you'll see that a uint8 is defined as an unsigned char. Now, an unsigned char is 8 bits long, and then that's why it's uint8, which makes it a single character, which is why it's a byte. So if we use byte, we can easily replace that with unsigned char, and that will work exactly the same way as byte. So that's what we really need to know here, is that byte and string are very, very interchangeable because they only differ in the amount of signedness. And if you're unfamiliar with C, signedness is whether an integer can be positive, or is whether an integer can be negative. If it's signed, it can only be positive, and if it's unsigned, it can only be negative. So we don't want to declare that there. We're going to declare a byte array up here, and we're going to call it like read. So byte read. And we're just going to make it an array by having it have 10 places. We don't really need this many, but if you're going to make it kind of a string, then you could easily do that. So because byte is interchangeable with unsigned char, I'm just going to replace it with unsigned char just to make it kind of easier to see how a byte is equal to a string. Because keep in mind that this is a byte, and only if we remove unsigned it becomes a string. So, or it becomes a character array, which a string is the location of that character array. It's kind of a hard concept to grasp, but I'm just going to go ahead and leave it as unsigned. And we're going to pass in that variable to the USB.read function, so read. And the only issue here is that you'll notice if we actually do USB.read, it takes a string, and a string, as we know, is a char star. So we need to add that star there. And we can easily do that by just doing, this is kind of interesting, by putting an ampersand there, and that actually turns it into the location of it. So no longer is this thing right here, is this argument really referring to the actual array of bytes, but now it is referring to the location of that array of bytes in memory. So it'll now work. Now next, if the first element in that byte array equals r, so this is actually moderately simple, we can just do an if gate, and then if read, and then the first element, which is 0 because arrays are indexed from 0, and if that equals r, and that is a successful comparison there. You do need single quotes here, because if you use double quotes, it's referring to the string itself, the string literal in C. Of that. So a string in double quotes, or in double quotes, you could have a bunch of different characters like that. But in single quotes, you can have multiple characters, but it would also be referring to the string literal. But if you only have a single character in single quotes, then it's turning that single character into a byte, or into an unsigned character in this case. So you can see we compare the first element of the read array, which, as you'll remember, is a unsigned character, and we're comparing it to the character r, so that should work successfully. So let me add some brackets here, and we're just gonna turn the red LEDs on. We can do that using the ledr.dutycycle function. All right, so now we've got the R command working. So if we send the Nestle board the letter R, then it will turn the red LEDs on, and we just want to make another command that is the O. So if read, and then the first element in that array, if it equals O, then we are just going to turn the red LEDs off. Alright, now to clear the byte array, we're going to use a C function called memset, M-E-M-S-E-T. Now this memset function will set the location of an array to a certain item for as many characters as or as many elements as we want. So we can have memset, and then our first argument is actually the pointer to the array. And the second element, or the second argument in this, is the what you want it to be. I guess I'm going to call it the reset character. So it will set that element in the array equal to something. And the last argument is how many characters you want to set it equal to. So how many characters, or how many elements, I guess. Alright, so for a pointer to an array, we could pass in read, but we really couldn't pass in read because read is the actual array of bytes. It isn't the location of them. So to turn it into a pointer, we're going to use the ampersand, which is shift 7, which is the pointer to the read array. And then for the reset character, we're just going to set each element in that array equal to 0 for the size of the array. So we'll use the C sizeof function, SIZEOF, and then that will take an argument called read, and that'll take the size of the read array. So imagine we have the read array. So this read array is 10 bytes long. We have like R for the first byte. So you see that has 10 bytes. Now this memset function is going to go through this for this many characters. So the size of it is 10 bytes long. So it's going to start here, and this is the location to the first character, which is in this first argument here, and it's going to set it to 0. And if this is just 1 right here, it would stop right there. But because this last argument here is the size of the read array, it's going to move on until it does that. So it's going to set this to 0, then 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 this to 0, and then this one to 0. So that's what that memset function is going to do, and through doing that you can see it clears this array, so it no longer contains any usable value, and in the next calling of the while loop it will start over with a blank array. So now if we go ahead and build this program, and we'll go ahead and program our NESI board and see if it works.
So you'll notice that when I turn on the NESI board and the blue LEDs illuminate, and I start monitoring on the computer. Now when I hit the R, or when I type in R, I hit right and I type in R and I click send, you'll notice that the red LEDs turn on the NESI board. And if I type in O, you will notice that the blue, or that the red LEDs turn off. So I can alternate between on and off on the red LEDs, and you could add more single character commands, or if you're ambitious, you could make an entire string of characters and have multi-letter commands.